In this video, we will talk about reading binary files. We have read text files using fscanf, right? We used fprintf to predominantly write uh, normal text files. But if you have binary file, the functions that are recommended to use is called fread for reading. Fread, it's something different from fscanf because it requires 4 parameters. We'll go here. To read binary files, use fread. You see that? Give me a second. Let me. I just changed the font to just fread. Okay, to use binary files, we use fread. It requires 4 parameters. One is the buffer from where you want to read into, right? Pointed to the buffer. For instance, you have your binary file, right? You have a binary file and you want to read this binary file into a buffer, your own buffer, internal buffer, say input. So let's see how a binary file looks like. All right. If you go back, I have a file here called Barbara PGM. If you see this file, see this is just the header first, which is in ASCII. 512 is the width of the picture, 512 is the height of the picture, the maximum value is 255 each pixel. But after that, if you see, there's a garbage. If I just come here, you see that it's all binary data, some garbage in here that it doesn't make any sense because there are binary files. They're not ASCII text files. Okay. So how do I read? Here is, if I go back to man pages fread, if you look at the function, it's a pointer, and size, the next two parameters are important. We will look into that now. What it says is, okay, first is the input buffer, we saw that, right? The second and third is, let's say you have a character that you want to read. It's all binary, right? And the second parameter says what the size of the unit, size, let's say size of the unit, and how many such sizes units you want to read, number of units. So in case of, this is the third parameters. Size of the unit is second parameter. Number of units is the third parameter in the function, right? Size and number of that. In case, let's say you want to read a characters. Let's say you want to read 5 characters, 5 bytes. That means size of the unit is 1, which is a 1 byte character, and you want to read say 5 of them, you say the first parameter we know pointer to the buffer, second parameter is the size of the unit, and number of such units you want to read. This is the third parameter. This is very important. A lot of people get confused. So just remember that. What is the size of the unit and how many such units you want to read. And the last parameter is the file pointer. File pointer. Okay, that's all it is. Fread. And here, let's say I want to read 10 integers. I want to read 10 integers. So in our case, integer is 4 bytes, right? So in that case, it becomes pointer 4 bytes, 4 units, or 4, the size of the unit is 4 because we know integers is 4. 10 integers, so you put 10 and file pointer. All right. In case you want to read 20 short integers, then it becomes 2 comma 20, right? This becomes 2 comma 20. So that is how it is. So it looks scary. This API looks wow. It don't make any sense to me, but that's what it is. Okay, and it returns the number of bytes read, number of units such read here, number of items successfully read. Okay, number of items successfully read. Okay, number of units means, let's say you go back here. Where is that? Yeah, if you ask for 20 units, it'll return. If it successfully read 20 units, it return 20. If it read 10 integers, it'll return 10, like that. Okay, so that is all about fread. So let's go back, and there's one more function that you have to understand, which is here. If you go back here, every time you use fread or fwrite, it is always better to use this function called fseek. Fseek is kind of, we read in the past, is anytime you open a file, let me erase this guy, sorry. Anytime you read a file, open a file, the file pointer, we talked about the file pointer. You can, let's say this, and it has a lot of data. This is the end of file. You can read from any part of the file. You don't have to just stuck to the beginning of the file. What if you want to read from the center, or you want to read somewhere here, or you want to read somewhere here? It's called random access random. Just like the CD player, a CD disc, you can read, um, you can play any song, right? So you can always position this file pointer anywhere on this file using fseek. And fseek also requires the file pointer. All right, it has 3 parameters: fstream, offset, and whence. It's kind of a weird name, but let me explain that to you. File pointer, offset, and the mode. Whence is called whence. Let's keep it same way. What it does is, where do you want to position your file pointer? Is it relative to the beginning of the file? Is it relative to the end of the file? Or is it relative to the current position? For instance, for in, for instance, you are playing, let's say, eighth song, right? You are playing the eighth song. You want to move back to the fourth song, or you want to move forward to the three songs from eighth, or you want to go one previous song, or you want to go to the beginning of the song. So that's relative positioning of the file pointer is what fseek is all about. So whence takes three types of values. One is, it's all uppercase, seek underscore start. Okay, that means from the start, let's say your offset is 10, 10. That means from the start, position the file pointer 10 bytes from the start. That means 10 bytes, whatever that is, the, the pointer will be 10 bytes. If you say fseek file pointer, say Tony, and seek start, that means from the beginning of the file, no matter where you are reading now, always go to the 20th byte. That's what it is. So seek underscore start constant, emphasis that it's the beginning of the file and offset should be computed from that. If your constant is end, that means my absolute position is end here, my file pointer is here, and if I give an offset of, say, this offset is now minus 10, that means from the end go 10 bytes backwards, put it here. That's what it means. Minus 10 means offset, minus 10 means with constant seek underscore end means go to the end of the file and rewind 10 bytes. If it is 30 bytes, rewind 30 bytes from the end. So you see how the absolute position is dictated by these two constants. Now let's say your file pointer is somewhere here, you are reading, just like you are listening to song 8, and you want to go to the next song. For that you say seek underscore current, and how many songs you want, how many bytes you want, let's say 1, means from the current position go 1 byte forward. All right, so these three things are important. Start, end, current. Okay, these three things are important. You always have to understand how it works. Okay, so whenever you use fread, or fwrite, you always have to prescribe the position of the file pointer using fseek. Otherwise, it will always start from the beginning. Okay? This is optional. Remember, this is optional, but it's always better to use it. Fwrite is also similar to fread. Okay, go through this slide for fseek. Ftell tells you where you currently are. It is asking like a CD player, which song are you playing now, right now? Okay, that's what it is. So it returns the length of the from the beginning of the file. Okay, write. Fwrite is similar to the fread. Instead of writing, you are instead of reading, you are writing. Oops. We will try to copy a image file using fread and fwrite. The example we are going to look now is there is a binary file, a picture. We're going to copy this file into another file. Okay, whatever it is. I'm artistically challenged, so forget about it. So we are going to copy this file. This is a binary file into another binary file. Okay, and the functions that we are going to use is the functions we are going to use is fopen, fread, fwrite, and this and also fseek. Okay, but there's a catch here. I want you to understand a little bit before we see the example. Okay, the picture has a header. The picture has a header, say first 15 bytes, and then the actual picture starts from here. Okay, this is a binary data. The whole thing is a binary data. Okay, and we are going to read this picture file, all right, directly skipping all these headers. Okay, how are we going to do that? Our picture is 512 bytes by 512 bytes. Our width is 512, height is 512. That means we know the size of the binary data, which is 512, sorry, 512, 512 times 512. So when we open this file, we are going to create a file pointer position where? Right here. So how would I use fseek to position my here? The way to do that is, the way I would do is fseek, right? We know the file pointer. Offset is 512 times 512 from the end of the file. And this has to be minus. It means backward. 512 times 512 seek end means from end of the file go all the way and position my file pointer and start reading one byte at a time. I will read one byte at a time, not a big deal. For now, I'll read one byte at a time. So 1 is the size of the unit and 1 is the 1 byte, and sorry, this is not be a, this is an internal buffer, not a file pointer. This is internal pointer, right? And this is my file stream. So I'm going to read one byte at a time from the file stream into a pointer by putting the fseek at this position. Okay. The reason I go from the end is because sometimes it could be 16 bytes, 18 bytes, I'm not sure. We don't want to dwell on that, but I know my picture file is 512 by 512, so I can be for sure if I do a fseek using this call, my file pointer will be there. Okay. For instance, if we go to the Barbara, my binary file starts in here. If you see, it starts from here. And if you look at this header, let's see how many ASCII characters are in here. 1, 2, 3. There's end of line here, right? It says P5. There's the end of line. 255, 255, end of line. There's a 255, end of line, and the binary file starts. So I have how many bytes I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, including the end of lines, right? So that's why 15 bytes. So 15 bytes here, including the end of lines in all the 3 rows, and the binary file starts here. So that's why I put a fseek from the end of a line, end of the file back in here. Okay. So we are going to read that file, Barbara PGM. So how does a Barbara PGM looks like? Okay, I'll show it to you. So this is how Barbara looks like. So we're going to copy this picture. Are you able to see that? Yeah, you're able to see it. So we're going to use this picture, read the binary file, and store it in another file. By the way, this is how Adobe Photoshop also works. Adobe Photoshop or any image editing software opens these files like this. They manipulate these pictures using different buffers. You read into a buffer and you can manipulate it. Okay, that's what we are doing right now. Okay. Okay, let's do this programming in the next video, and because it requires a little bit more programming, so I want you guys to pay attention. and see how it is done.